It's really been a while since I uploaded a Leetcode vid. This is 2424 longest uploaded prefix. Kid, let's go ahead and get right into this problem. So you are given a stream of n videos, each represented by a distinct number from 1 to n that you need to upload to a server, okay? So I have video 1, video 2, video 3, so on and so forth. And I'm going to upload these videos to a server. So I'm going to upload video 3 and video 1 and video 2, whatever. You need to implement a data structure that calculates the length of the longest uploaded prefix at various points in the upload process. Okay. We consider I to be, so this is a little weird, right? Because it's like upload prefix. So I'm guessing like, right, when I'm reading this, you know, if I've uploaded 1 and then I upload 4 and then I upload 5 and then I upload 3, well, the longest upload prefix would be 3, then 4, then 5, right? So another way you might want to say that is if you have, you know, n videos like this, right? You could say, okay, well, we'll index them here, right? So this will be video 1, 2, 3, 4, 5. Maybe there's 5 videos. And we could say, well, okay, maybe we uploaded video 1, and then we uploaded video 4, then we uploaded video 5, and then we uploaded video 3. And you can see from this example, the longest prefix would be 3 right here, right? Because you have 3 in a row. So it's like, how many in a row have you created? Okay. We consider I to be the uploaded prefix if all the videos from range 1 to I have been uploaded to the server. Interesting. So this doesn't count then, right? Because it has to start at 1. So the longest prefix starting at 1 would be 1 itself, right? But if we ended up making this a 1, for example, right, then the longest prefix would be 1, 2, 3, 4, 5, right? Because we end up uploading all these videos. So the longest prefix starting at 1. So really stated in more of a rudimentary way, the most consecutive ones, the number of consecutive ones starting from 1, right? It could be 0, right? Like even if the whole system was like this, right, the answer would be 0 because it has to be, we consider I to be an uploaded prefix if all videos from the range 1 to I inclusive have been uploaded to the server. So even though 2, 3, 4, and 5 have been uploaded to the server, since 1 hasn't, right, we can't count this as an uploaded prefix, right? Because it's all videos from the range inclusively from 1 to whatever, right? So without 1 uploaded, nothing can be considered, which is something interesting to think about. Okay, so we want to implement the LU prefix class where the LU prefix int n initializes the object for a stream of n videos. Okay, so we'll create this kind of video array saying all the videos that we've uploaded. I mean, all the videos that could be uploaded. And then when we upload a video, you know, if we upload the video 3, it sets this 3-bit to 1. So we're basically saying, okay, we uploaded 3. So in this scenario, we don't know the order. I mean, we know the order from here, but maybe we uploaded 1, 4, 5, and 3, and then you would have this, you know, every time you upload a video, you have to somehow articulate that you've uploaded that video. And then when you call longest, it's going to return that longest prefix starting from 1, right? The number of consecutive ones starting from 1, right? And, you know, this is just one way of implementing what it's going to look like on the back end, right? There's a bunch of ways you can think about how am I going to implement the back end, right? How am I going to, you know, log and keep track of what videos have been uploaded, what videos haven't been uploaded, and how am I going to efficiently keep track of the longest prefix given everything that's been uploaded so far, right? So these are the kind of things you kind of think about when you design a class like this, right? And it's a good design problem. It's also just a good, you know, not simple, but, you know, somewhat fundamental data structure and algorithm problem, right? So for example, when we have LU prefix, in this example, right, so we start with LU prefix. So the first call to this function, right, is my tablet breaking down on me, right? The first call in this function is you have LU prefix with 4, right? So when you call LU prefix of 4, right, that's going to create a system where you have 4 videos, right? So however you represent that is up to you. And then we upload 3. Okay, so that means we uploaded the 3rd video. Then we want to say what's the longest one. Well, the longest one here, this is going to return 0 because we haven't uploaded 1 yet. right? So the output is null, right? This doesn't return anything. So we think about the outputs. This is null. Okay, I'm going to write them all down, and then we'll go through it, okay? Sometimes you got to think about these things, okay? So then we call longest with no argument. Then we call upload on 1. All right, so then we upload 1. We call longest again on nothing. We upload 2, and then we call longest again. We upload 2, and then we call longest again. Okay, so everything except for longest doesn't return anything, right? These are all voids, right? LU prefix is the constructor, it's void. Upload is void, so those will always return null. So we can quickly just say, okay, this is going to return null. 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 And longest is going to return something. So what do these longests return? Well, we see these first two nulls, right? Null, null. Now, what's the longest return? Well, first, I mean, we can try to put this in our head, but let's think about how we're going to represent this with the data structure. And I think what I used before would probably be the most intuitive thing, right? That's probably what you would think of too. Like, okay, well, I need to flag what has been uploaded, what hasn't been uploaded. That way I can figure out, the longest prefix. So we'll create a little data structure here, right? In the back end, we'll just say, okay, here are the movies, right? And there's 4, right? So I'll make this thing of size 5, just so we can reference each movie, 0, 1, 2, 3, 4, 5. I'll just make it like this. We're using an extra space, but it's constant extra space, so who really cares, right? We only need to represent flags for all 4 movies, but this is just easier because I can say, okay, when I upload 3, what am I doing? I'm saying movies at 3 equals 1, right? That's what I'll do here. When I upload 3, I'll set movies 3 to 1. So then the array will be 1, 0, 0. And then when I return longest, well, what's the longest here? Remember, the longest has to start from 1. 1 is 0, so this is going to return 0, right? There's no prefix because 1 hasn't even been set yet. And then I upload 1. So when I upload 1, what I really do is I just set movies to 1 equal to 1, right? Now the longest is what? Well, the longest, the number of consecutive ones starting from 1 is just 1 itself, right? I have a 1 here, so there's 1. This is a 0, so there's just 1. Right? And then I upload 2, so that means I'm going to set movies of 2 to 1. So this becomes a 1. Probably should do it like that. This becomes a 1 here. So now the longest is, well, what's the number of consecutive ones starting from 1? So there's 1, 1, then there's another 1, then there's another 1, then there's a 0. So there's 1, 1 in a row, there's 2 1s in a row, there's 3 1s in a row, there's 3 longest. So this would return 3. And then we'll see that here, right? So we get null, null, 0, null, 1, null, 3, null, null, 0, null, 1, null, 3. Okay. So we kind of get the general idea, and we kind of already determined an inefficient way of calculating the longest, to solve this problem, right? We can create a movies array, and every time we upload, we just set it to 1. And then when we want the longest, we just roll through starting from 1 and counting the number of ones that we've encountered, right? And, that is like end time, right? Because every single call, we're going to have to go through the whole array to figure out, right? Like basically what we just did, if what I'm saying doesn't make sense, is right, you just do your uploads, and then when you call longest, you just have a loop that looks through, okay, how many consecutive ones are there in a row? And then whatever that is, you return it. But the problem is that means for each call to longest, you could end up looking at almost all of the array, right? Because you're going to look at all the array to figure out, you'd have to look at the number of consecutive ones to determine how many consecutive ones there are. I'm rambling like crazy today. But the idea is, if I want to find the longest starting from 1, then I'm going to have to look through the whole array to figure out how many consecutive ones in a row there are. So every time I call longest, I may end up looking at almost all of the array. So that means for n elements, I'm going to have to do a call that costs n time every time I call longest. And if you see here, there could be 2 to the 5 to the 10, 2 to 10 to the 5 calls to longest, and n can also be 10 to the 5. So we could have 2 times 10 to the 5 calls to longest, and each of those longest calls could cost 10 to the 5 time. So that means that there could be, in total time, that's 2 times 10 to the 5 times 10 to the 5. So 2 times 10 to the 10 total operations, flops, whatever, right? That could be the possible big O runtime. So that's far too slow, right? So we need a better way, likely using a prefix or some prefix like Notion, to represent this movie array. That way, you know, when we call longest, it happens in constant time. Because if longest takes n time, if it takes proportional to the size of the array, the number of movies, it's going to take far too long, right? Because you're going to have to do 2 times 10 to the 5 calls already. So if that each of those calls takes 10 to the 5 time, it's going to take way too long in order for this to work. Now, I have looked at solutions after I solved this, you know, full disclosure, I've already solved this problem, where other people kind of used a approach where it has a loop, but then they use some, you know, complex math to prove that amortized, right? Like in general, on average, right? In most cases, it's going to be constant time. And that solution works, but there's actually a manner in which you can do this where it is definitely constant time. And it just requires a little bit of finesse, right? It requires a little bit of a trick. I haven't seen anybody else in any other answer use this approach. So either, you know, it's just too annoying for them to do, or the amortized time one was sufficient for them, or they just didn't know about it. I don't know. But this is kind of a unique approach that you probably won't see other places. If you see it somewhere else, or if this is something you thought of, please comment below and let me know. Like, it's just interesting that I haven't seen another approach like this, because I don't know, I felt like it was, you know, it is the best approach. It's not amortized constant time like someone else's. There's no loops required, and you get the answer pretty in a finesse manner, right? So how are we going to do this? Well, you know, the issue is with this system is, you know, we need to keep track. In order for this to be constant time, when we want to find out the longest prefix at 1, we need to know the length of that system, right? We have to know. We have to know what? We have to know when we make a call to longest in constant time, we have to already have information about the longest prefix at 1. So how do we collect the longest prefix at 1 in this system? Well, let's just go through a couple simple calls and see if we can derive maybe some sort of solution, right? So let's just imagine we have a bunch of zeros here. Okay. So I'm just going to do a quick example to try to articulate kind of generally how this is supposed to work, right? So let's say these are our movies, and then we start doing a few uploads, right? This is 1 here. So I'll just reference them here. Okay. So what we want to have to keep track of is the longest prefix at 1 at all times. That way, when we call longest, it happens more efficiently. We don't have to traverse the whole array to find the answer. Okay. So let's say we upload movies 2 and 3. Let's say we upload movies 2 first, right? So what if we need to somehow keep track of the longest, we need to keep track of the longest like prefix at any point, right? And then say we then upload 4 or 5, let's say 5 at 5, right? So when it looks like this, well, the longest is 0 because 1 hasn't been set. So there's not even one consecutive one to look at. And then we have these 2 prefixes of size 1, right? But we need to somehow capture the length of all the prefixes within the system in order to, find this answer. Let's add something a little bit more interesting now, like 4. So when we add 4, well, these all say 1, but what I want to do is I want to capture the length of the prefix involved. So now we have a prefix here of size 2. So we want to update both of these to 2, right? And then what happens if we make, let's say we set 7 over here and a couple other random things. We set 7 over here. And then what if we set 3 here? Well, here's where it gets tricky, right? Because when I set the 3 here, well, now it should be length 4, right? And what you can kind of think of is, well, if I have a system where I'm setting the system like this, if I'm setting this bit, then the length of this entire substring is everything to the left and everything to the right plus 1, which is me, right? So when I set this third bit here, when I upload this third movie 3, well, what's going to happen? Well, it should be length 4 now, right? So what happens is, well, I become a 1, right? And then I can just keep track of the size on the corners, right? So I can say, okay, I keep a 1, and then I'll set both of these to 4 on the corners. Because the corners are the only thing that matters, right? Because when I attach to something, I'm looking at its corner to determine the length of the system, right? So if this thing has length 4 going this way, so I'm trying to think about how I'm going to articulate. Let's say there's something of length 5 going this way where it's all consecutive ones. And then, so that means it would look like this actually. So there would be a 5 here, 5, and then say we had a 0 here and a 4 here, a 4 here. Right? So in this example, what it basically means is, well, there's a prefix of size 5 on the left side, and there's a prefix of size 4 on the right side. So how would I combine these to make, if I made this a 1, there should be a new prefix like this of size 10 here. Okay, so that's the general idea behind this problem is, well, when I connect these, I'm going to get 5 on the left, 4 on my right, and then I become a 1, so I add 1, right? So I get the 5 on the left, I get myself when I convert me to a 1, right? And then I get the 4 on the right. So then in order to represent this using the edges, well, what do I need to set? Well, if I'm uploading, let's say uploading. If I'm uploading movie I, okay, so we're saying I'm uploading movie I, so let's call this I. Well, I'm combining everything to the left and everything to the right, okay? So basically what I'm doing is I'm saying, well, my neighbor to the left, its length, right, is the value at that thing. So I'll call that movie at I. So we'll call it, so I get, how am I going to articulate this right? So if this is a 5 here, that means that there's something length 5 to my left. So this is -1, -2, -3, -4, -5. Okay, so I say movie at I minus movie at I minus 1. So basically what I'm saying is, because this is I minus 1 here, right, and this would be I plus 1. Right, so I'm saying, if I'm uploading at I, and that doesn't equal this, I'm just saying this is what we're going to do. I'm all over the place today, man. I might even end up recreating this video. I don't know. Okay. If I'm turning I on, well then I'm going to upload the left and upload the right because I want to make this 5 a 10 and this 4 a 10. Right? So I'm saying, okay, well, I'm connecting to you to the left. So at your edge, you're going to make that edge a new value. So you're going to make that new edge what it used to be, right, which is the edge value before, right, because now it has 5. So I'm going to its edge. I'm saying, okay, you're length 5, so I'm going to go 5 over to get to your edge. So -1, -2, -3, -4, -5, right, and +1, +2, +3, +4. So I'm going where I'm at, the movie I'm uploading, and I'm going to the old prefix's edge. And I'm saying now your new value is 10. Well, how do I know that? Well, the new value is going to be what it used to be +1, because plus me, right? And I'm going to move this over so we can put this all in one line just because it's already way more confusing than it needs to be. Right? So now on the new edge, I'm uploading to be 10. Its length is what it used to be, 5, right? Because it's still 5. I'm not making anything 0. +1 to think about me because I'm adding me to the equation. So we're going to color code these. So we'll make this one green. We'll make this one over here red. And we'll make this one blue. Okay. So I'm uploading the old one's length, right? I'm adding myself, and then I'm going to add the new one's length. So what's the new one's length? Well, that's that is m of I plus 1. Like that. Right? Because that's this new one's length. So I'm saying my new edge's length all the way over, right? Because now I'm like connecting these two components to each other, right? There was one isolated component to my left, one isolated component to my right. Now that I'm in the equation, they get to connect to each other. So then I update its edge on the left and I update its edge on the right with the new length of this system, right? So that's what I do to this system. And then at the same time, what I need to do, we'll make this green to specify what I'm actually adding here. So I updated this left edge, and then I need to update this right edge as well. Right, so I'd say m of I plus m of I plus 1 equals m of, it's the same thing, right? Because they have the same length now that they're connected to each other. Right? And then this would be the red one here. So hopefully you can see the color code of how this is supposed to work, right? If I have a component to my left and I have a component to my right, if they're disconnected, all I need to do is throw myself into that equation, right? And then I say, well, then now my new system, the left will have length 10, the right will have length 10 because I'm connecting them to each other. And you'll notice that'll work with anything, right? This equation will even work if you have like one, right? What if you have zeros on both sides and then you add something here? Well, this would just be I minus 0, so it would still be I, equals I minus 1, which is 0, plus 1, which is itself, plus I plus 1, which is 0. So this would be 1, and then you'll do it again, and it'll set it to 1 again. So it's not going to mess with anything if you do it like this, right? Even if you add something that's just a 1. If you did something with just 2, right? So imagine this was a 1 like this, then you had zeros in this system. I'm just giving you a quick example to show you kind of, you know, a case where it works. I'm not going to prove to you that this works in all cases because I've proven to myself that it does, but this is generally just the idea, right? So if I add a 1 here, well then minus 1, so I minus 1 will be I minus 1, which is 1 plus I plus 1, which is 0, so this will become a 2. And then I plus m of I plus 1 plus I is 0, so it will be here, equals m of I minus 1, same thing, equals 2. Right, so you can see how this works for 1, this works for 2, and then you can kind of see the general case here that it works for something greater, right? So this is kind of the equation you can use to, you know, in real time when you upload, keep track of the longest prefixes. So when you want to just know the longest prefix when you want to know the longest, well, you're trying to find the longest prefix that's at 1. So you just return m of 1. And that's it. Right? And you might say, well, you know, this only keeps track of the length at the edges, right? When you actually update this system, you're still going to have the 5 in here and the 4 in here and maybe a 1 in here or something, right? So you might be inclined to be like, well, you know, you're not keeping track of actually like you're not keeping track of what's actually like already been, what am I saying? Right, like, what if 1 is within the center, right? Because we only know the links at the edges. So since we only know the links at the edges, what if 1 isn't the edge? Well, since 1 is there's only 1 to 10 to the 5 videos, right? 1 is always going to be an edge because there's no 0th video. So there's no video on the left to add to. So you're never going to have something that's a case where 1 isn't at the edge, right? Because 1 is the edge and then going forward. So this will always keep track of the links at the edges of all the prefixes. And 1 always and it just so happens that 1 is always going to be an edge of any of the prefixes. So then it'll always capture the length of the longest prefix starting at 1 because that'll always be an edge. Okay. So then all we need to do is then create this system and go for it. So all we need to do is we just make our m. We'll call it self.m. And we'll make it 0 times, and then, you know, when you upload the last video, it's going to try to check something on the right. And when you upload the first video, it's going to try to check something on the left. So we might as well just make, if there's 5 videos, so n plus 2. So we'll capture the 0th video on the left and the non-existing video on the right. So this just gives us a little buffer so we don't need to make edge cases so we don't go out of boundary, right? We'll just never upload those videos, so we don't need to really consider the implication. It just protects us from having to think about, like, okay, what if we go too far left or too far right when we add things? We'll just create a little buffer, all right? So then when we upload a video, well, all we have to do, well, first we want to make sure that we haven't already uploaded this video, because we don't want to upload something, right? If we already captured the edges, this could screw up if we try to redetermine what the edge links, or will it? Actually, I don't think it will, because if you re-upload a video, it can only be longer. If it's shorter, then it's still going to be within the boundaries of those prefixes, right? So now we just have to run this equation. So m of I, the video that we're uploading, so I called it I, but it's actually video, right? So we say self of I of video minus self of m. I called it m for movies, I guess. I don't know. Video minus 1. Video minus m of video minus 1. Video minus m equals m of I minus 1 plus 1 plus m of I plus 1. Okay. So m of video minus 1 plus 1 for ourselves plus m of video plus 1. So we don't need this if. And then we need to do the same thing at the same time for the other value. So then we'll also set that to the same thing. And then at the longest, well, then the 1 is always going to be an edge, so we just return self.m of 1. No loops, no amortized time. This is purely constant in its approach. $30 filmer. Regex flag is not. $30. All right, what did I do wrong here, guys? Someone somewhere in the universe is screaming at me right now because this is okay. The video minus self m video minus 1 in self.m video minus self of m video minus 1 plus 1. This should be plus 1, but it errored for different reasons, so I'm kind of curious what I did wrong here. Dirty money. Regex object is not subscriptable. What? All right, little debugging here, looking like a fool. Isn't it? Guys, what am I doing wrong here? It should be plus 2. Man, I'm screwing everything up, man. Oh, forgot the self here. Can't believe it took me that long to notice that, dude. Yikes. Don't do that interview. You will definitely not get the role if you don't notice something extremely obvious. All right. That should do it. I'll get rid of this print. That's embarrassing. All right. Dirty money. All right, cool. So what's the run? And so to do an init, right, we just have to create an array of size n. So I guess you could allocate the space and they would all be zeros, but we'll just say it's O of n. Time and O of n time. Uploading is going to take constant time. Right, you just upload the video, so you just set a few things, right? I set one variable based on another, based on another. I'm just setting two things based on the value of a few things, so it's constant. And then returning longest is I just return the value itself of M1, so that's constant time too. So in total, right, if we have n movies and n calls, or we'll call it m calls to upload and longest, well, we have to create, in terms of space, right, we have to create this array to keep track of, you know, the prefixes within the movies that we've uploaded. So for space, we'll call that O of n, because we have to create an array of size n. And then for time, well, we're going to create this array, so we'll call that O of n time to create the array. Now it doesn't matter, actually. Damn it. O of n time to create the array, and then we'll have m calls to upload. And before it'd be O of m of n, right? Because for every call, we'd have to traverse the whole array. But now, since we're using this little prefix, you know, edge corner case idea, that is now constant. All right, guys. Not my best video. I might remake it. This is what happens when you don't upload constantly and you have a job where you don't have to talk too much. So your language skills start to suffer a little bit. All right. Peace out.